Welcome to this presentation on representing real numbers on a number line by the process of successive magnification. Real numbers constitute rational numbers and irrational numbers. Rational numbers, when converted to their decimals, are either terminating or non-terminating recurring decimals, whereas irrational numbers are non-terminating, non-recurring decimals. We shall see how to represent rational numbers on a number line and which can be applied onto irrational numbers also. Let us consider a terminating decimal 4.8. 4.8 lies between 4 and 5 on the number line. So the part between 4 and 5 is magnified and the enlarged segment is subdivided into 10 equal parts, which is numbered as 4.1, 4.2, so on, 4.8, 4.9 and then 5. So on the number line, we can see that 4.8 is located at this position. Now let us consider another terminating decimal 2.34. 2.34 is a decimal which is greater than 2 but less than 3. Hence 2.34 lies between 2 and 3 on the number line. The segment between 2 and 3 is subdivided into 10 equal parts numbered as 2.1, 2.2, 2.3, so on, 2.8, 2.9 and 3. Obviously, 2.34 is a number which is greater than 2.3 but less than 2.4. So the number is located between 2.3 and 2.4. The part or the portion between 2.3 and 2.4 is magnified and the magnified segment is further subdivided into 10 equal parts, which is numbered as 2.31, 2.32, so on, 2.34, 2.35 and so on, 2.38, 2.39 and 2.4. We have obtained the required number 2.34 on the number line marked in a box. Now let us consider a non-terminating recurring decimal 2.7 bar. 2.7 bar is 2.7777 so on, which is a non-terminating string of decimal 7. 2.7 bar is a number greater than 2 but less than 3. Hence it is located between 2 and 3 on the number line. As in the previous cases, the portion between 2 and 3 is subdivided into 10 equal parts and numbered as 2.1, 2.2, 2.3, so on, 2.7, 2.8, 2.9 and 3. The segment between 2.7 and 2.8 where 2.7 bar lies is further magnified and the enlarged portion is further subdivided into 10 equal parts numbered as 2.71, 2.72, 2.73, so on, 2.77, 2.78, 2.79 and 2.8. Clearly, 2.777 lies between 2.77 and 2.78. So the segment between 2.77 and 2.78 is magnified and the enlarged segment is again subdivided into 10 equal parts numbered as 2.771, 2.772, 2.773, so on, 2.777, 2.778, 2.779 and 2.78. Clearly, 2.7 bar lies between 2.777 and 2.778. We can proceed endlessly in this manner successively viewing through a magnifying glass and simultaneously imaging the decrease in the length of the portion of the number line in which 2.7 bar lies. Now let us consider another rational number 6.2445. 6.2445 lies between 6 and 7 on the number line. And this part between 6 and 7, which is enlarged, is subdivided into 10 equal portions, that is marked as 6.1, 6.2, 6.3 and so on. 6.24 is a number greater than 6.2 but less than 6.3. So 6.2445 lies between 6.2 and 6.3. This segment is magnified and the magnified line between 6.2 and 6.3 is further subdivided into 10 equal portions marked as 6.21, 6.22, so on up to 6.28, 6.29 and 6.3. 6.224 is a number that is greater than 6.24 but less than 6.25. So it lies between 6.24 and 6.25. This portion between 6.24 and 6.25 is magnified and the magnified segment is further subdivided into 10 equal parts numbered as 6.241, 6.242, so on up to 6.248, 6.249 and 6.225. 6.244 lies between 6.2445 lies between 6.244 and 6.245. So the segment between 6.244 and 6.245 is magnified and the magnified portion is further subdivided into 10 equal parts numbered as 6.2441, 6.2442, so on 6.2448, 6.2449 and 6.245. And on the number line we have obtained the required number 6.2445 marked in the image. This process of visualization of representation of numbers on the number line through a magnifying glass is called as the process of successive magnification. The same procedure can be used to visualize a real number with a non-terminating, non-recurring decimal expansion on the number line. Thank you.